Okay, so hi there folks, we're now in our next video in the mathematics in the modern world, and here we're going to talk about the use of numbers first, and then eventually we're going to talk about the unary and binary operations. So for the use of numbers, this is quite a short one slide presentation. So we have three uses of numbers of how they are used in how we use them or their functions in short. So first of the use of numbers is, or they are called the cardinal numbers. These are numbers used for counting. So primarily it answers the questions how many. Okay, how many. So for instance, how many cars do you have? Okay, two. How many pens do you have? Say 15. How many notebooks do you have? 21. How many laptops you have? One. How many cell phones? Three, and such. So these are very fairly simple examples. Second is, or are ordinal numbers. These numbers tell you the position of a thing in a certain list. So for instance, we have first, second, and third, and so on. I think you know the rest. And ordinal from the word order. Okay, order. And we have lastly, nominal numbers are just numbers used for identification or classification purposes. So only for classification. So such as, for example, we have Kobe Bryant's number, which is 24 in the Lakers. Okay. And we have the zip code of Bacolod City is 6100. Okay. So those are the use of numbers. Again, we have numbers used for counting. We call those cardinal numbers. Numbers used for telling you the position of a thing in a certain list, where we call that ordinal numbers. And we have also numbers for naming, which is nominal numbers. So we have three. So that's it for the use of numbers. We have then the next topic will be the unary and binary operations. So we're still in the mathematics in the modern world. When you say unary operations, it only accepts one operand. When you say operand, this is only one value when they do the arithmetic. So an operand is only one number in short. Okay, just one number. So it only accepts one number. So for instance, we have the plus and the minus signs when attached before a single number is read as positive and negative signs. So these are called unary operations, such as plus 3, or we just call it 3. These are unary operations. Negative 4, okay, unary, because there's only one negative, there's only one operand or one number. Negative 25, and so on. So let's talk about first the unary operation, which is positive or called positive. So consider the expression plus 4 or positive 4. So we read this as positive 4, okay, not plus 4. This does not mean we add 4. Okay, it means that it lies on the right side of the origin of the number line. So meaning positive 4 is somewhere over here. So it lies on the right part. So that's why it's called positive 4. Does it mean that we are going to add 4? So the value of 4 is considered as a single operand by the unary operator plus or positive, and that it produces a value of positive 4. Okay? Note that there is an invisible positive sign which exists before any number. Hence, when you say plus 4 or positive 4 or just 4 without writing the positive sign is still the same. So I think that's understood. So when you say you have the number 8, this is understood to be positive 8. Okay? Without even writing the the positive sign. So for instance, you have positive 10. This can be understood or can be written as just 10. Now, for the negative unary operation, the negative or opposite sign is also a unary operator. We have this symbol here. Consider the expression negative 4. The negative sign operator rather accepts a value of 4 as its operand, that's the operand, and produces the value of negative 4. Okay? And when you say negative 4, it means that it's on the opposite side of the number line. That is, it's on the left side. So if this is 0, the left side of the origin, rather, of the number line, 1, 2, 3, 4. So we have negative 4 here. So it's on the left side of the origin. There is no negative or invisible negative signs in math expressions, you really need to write that. Okay, in math, so if you intend the number to be the operand to be negative, so hence negative 4 and 4 represent different values. So unlike with 4 and positive 4, they are the same. Okay, but negative 4 really needs to be strictly written. I mean, the negative sign must be strictly written. Just remarks in the unary operations. Unary operations involve only one value, or we call this our operand, right? One operand. So more examples of unary operations. So we have the negation, in which we have discussed trigonometric values. So sine x only needs one value. Cosine 45, tangent pi over 3 only needs one operand. Single variable functions, okay, only has one operand. We have factorials. So we have 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So there's only one operation, which is the factorial, and it only involves one operand. We have the transpose of the matrix, in which we will not discuss here, but if you want, you can find this in linear algebra. Linear algebra. Note that this is still a unary operation, and we have, of course, square roots. So the radical is a unary operator, and we have only one operand, which is the radicand. Um, that is the radicand. Okay, so those are unary operations. Now, for the binary operations, from the word bi, or from the prefix bi, which means two, okay, so an operation is binary if it takes two real numbers, as you can see here, as arguments to produce another real number. So, for instance, if the plus, this signs here, acts on two operands, so not only on one operand, but two operands. So among the binary operators, the plus and the minus require more attention than any other binary operations. Okay, actually, why is that? Because we also consider these values in the unary operations. Likewise, we could also consider it in the binary operations, but they have the same, but they have different meanings. Okay, so recall that double negative is equal to two negatives make a positive. Okay, consider the expression 3 minus negative 2. So we read this as 3 minus negative 2. So take note, the negative sign operator has the precedence of the subtraction operator. So it accepts all the operands first. It is of precedence, the negative sign, because it's closer to the value of the app, or it's closer to the operand in short. So it's closer to the operand, so it has the precedence over the subtraction. Okay. Now, for instance, so we have here, we write 5 is equal to 3 minus negative 2. This is also equal to 5 equals 3 plus 2. Hence, we say that 3 plus 2 is equal to 3 minus negative 2. So then we put the parenthesis here to indicate that this is a negative sign, or this is a subtraction sign, this is a negative sign. So we differentiate. In some books, they will really um, emphasize this, that we differentiate the binary operation with a unary operator by writing the unary operators at the top, usually the top right of the operand. So for instance here, we may write this as 5 equals 3 minus negative 2. Okay, so this is equal to 3 plus 2. Why did that happen? Since this negative sign and this minus sign, okay, multiplying them will give us um, a positive one. So this is equal to 3 plus 2. So negative times negative is positive. Okay, so that's it for our binary and unary operations. Also, this is the end of our video, which involves the use of numbers. So for this video, thank you very much for watching. I hope that you would like and also subscribe and take a look at my playlist in mathematics in the modern world. Okay, so you will learn more. Okay, so thank you.